Thanks for joining me again here at Math Rocks with Mr. Cox. This video is going to be about graphs, and by now you've learned about how to do quadratics or parabolas or square root graphs or absolute value graphs. And this video is going to introduce two new types of graphs. One of them would be sine x, one of them would be cosine x. And if you want to find out how that works, just stick around and you'll find out. Let's get it on! As we go ahead and get started here, I just want to have a little disclaimer. This is really meant just to be an introduction to how to graph y equals sine x. There's things you can do to modify the graph like you can with other graphs like parabolas and absolute value graphs, etc., etc. But I just want to show you the basics of what a sine curve looks like and also later a cosine curve. So what I did is I made a chart. And by the way, we're in something called degree mode, and your calculator should have two kinds of modes for graphing these kinds of functions. We have degree mode and we also have radian mode, and I will discuss radians in a future episode and video, but I have degrees in here. So I start out at 0 degrees and I skip by 15-degree increments here. So from 0 to 15 to 30 to 45, etc., etc. Plugged it in, so I just found the sine of 0 degrees was 0. The sine of 15 degrees is 0.26. Of course, that's rounded off too, so it's just approximately, and so forth and so on. Kept doing it all the way up to 360 degrees, and over here you'll see what happened. And what you'll notice is it forms a curve, and it's called a sine wave here. And it starts at 0, and it reaches a peak up here of 1 when x is 90 degrees. And the lowest it goes is -1, and that happens actually at 270 degrees. And then heads on back to 0 here at 360 degrees, which kind of makes sense because if you think about a circle, at 360 degrees, we're back where we started again, and we clearly are back at 0 again here, and we're also heading uphill at this point as well. A couple things I just want to point out about this. Number one, because it does end up repeating itself, and let me in fact show you what it would look like if we expanded this out even further than just between 0 and 360. It would look like this, and this is the curve I just shown you right here that's highlighted in blue, and you'll notice it just keeps repeating over and over again. And since it starts at 0 and at 360 it repeats and starts going uphill again and repeating the same pattern here, we talk about it having a period. So a period is how often it would be repeating itself, and the period in this case would be 360 degrees. Also, there's another thing that sort of you can define this graph, and that is the center line here of the graph is when y equals 0, and the highest it goes is 1. So we talk about something called an amplitude, and I'm just going to say AMP for sake of brevity here. So amplitude here would be 1. Okay, and either you can go from the highest to the lowest, and then that would be a distance of 2, and then divide by 2, or you can just go from the center line up to the highest, and that would be your amplitude. And so, like I said earlier, you can modify this. Like, for instance, you could have sine of 2x, or maybe you have a 3 out in front, and that'll make the curve look a little bit different, but this is just the basic parent graph of what y equals sine x looks like. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. So now let's take a look at y equals cosine of x. And in this function here, once again, I went from 0 all the way up to 360 degrees, and I skipped by 15 degrees. And you'll notice the same thing is happening here, except for a major difference. Sine starts at 0 and then starts heading uphill like this, where cosine starts at 1 and is starting to head downhill, and then get down to -1 and head back up again, and then go back to where we started here. So cosine curves look a lot like sine curves. It's just where it starts is a little bit different, and like I said, sine goes uphill at 0 degrees, whereas at 0 degrees, cosine is going downhill. And here's what it looks like when you go from -720 degrees all the way out to +720 degrees. Same sort of thing here, it just repeats. Once again, it's going to have the exact same period. I'm going to shorten it up and say PER this time, 360 degrees. And this also has an amplitude of 1. And once again, it's not that different from sine. Sine would be starting here at 90 degrees. It would be going up to here, 180 back to 0, 270 down to -1. and then at 360 back to 0. So the sine curve would look something like this. So you'll notice as I draw this out here, and hopefully I can draw my curve a little bit better here, that it almost looks like you could take cosine and shift it over 90 degrees to the right, and it would actually land on the sine curve. And then that's true, you can actually do that. So with all that being said, that's really the basics of what a sine curve and a cosine x curve looks like. Hope you enjoy the video and stick around for other ones about the unit circle and about how to convert from degrees to radians. Thanks for watching.